Good morning, everyone. Today we'll be discussing about sustainable airline reservations, a key factor in making aviation more environmentally friendly. We'll explore the impact of aviation on the environment, how airline reservation influence sustainability, and how data-driven analytics can help airline reduce emissions while improving efficiency. So let's get started by understanding aviation's environmental impact. Aviation is one of the most important sectors in global transportation. It connects people and economies, facilitates trades, and enhances mobility. However, air travel is expanding rapidly with millions of flights per year, making it one of the fastest growing sources of carbon emissions. Aviation contributes to 2 to 3% of the global carbon emissions. That might sound small, but here is the problem. It's one of the fastest growing contributors to climate change, and this isn't slowing down. The demand for air travel is increasing, which means emissions are expected to rise even further in the upcoming decades. Now, let's break down the main factors contributing to aviation's carbon footprint. So the first one is the fuel consumption. Aircraft rely heavily on jet fuel, producing significant amount of carbon dioxide. Second is the inefficient routes. Flights often take longer than necessary routes due to air traffic congestion, regulations, and inefficient scheduling, increasing fuel burn. And also more people are flying than ever before, increasing overall emissions. Now let's look at this line graph that highlights airlines carbon dioxide emissions over time. The graph shows global carbon dioxide emissions from 1940 to 2019, and we can immediately see a consistent upward trend. By 2019, the emission actually exceeded 1 billion tons, showing no sign of slowing down. So let's look into another graph. Here, it gives a different perspective. It shows aviation shares of total global carbon dioxide emission from 1940 to 2021. This percentage started below 0.5% and increased rapidly in 1960 to 70, and then remained like around 2% in the recent decade. 2023 to 2024, it's higher than this. However, we see a sharp drop in we can see a sharp drop from 2020 to 2021 is due to the COVID-19 pandemics, where travel came to a halt. So what those charts tell us is clear. If airlines emissions are rising steadily, and its contribution to global emission is significant. So unlike cars and buses, where we are seeing electric alternatives, aviation doesn't yet have a large-scale solution like electric planes or hydrogen fuel that can immediately replace jet fuel. That means we need to look into other ways to cut emissions, like optimized flight operation is like big one. So as the demand for travel continues to grow, it's crucial that we focus on sustainable strategies to reduce airlines' carbon footprint while maintaining efficient global transportation. So we talked about fuel and route inefficiencies contributing to emissions. So what about airline reservations? How do they fit into sustainability? We might not think of it as a major factor, but they play a significant role. Reservation impact flight scheduling, route planning, and passenger load factors, all of which affect emissions. So when flights are underbooked, they still burn the same amount of fuel, but with fewer passengers, increasing emissions per person. Inefficient reservation leads to last-minute changes, extra stopovers, and higher fuel consumptions. The solution is a data-driven reservation system that can improve seat allocation, predict demand, reduce unnecessary flights, and many more other things. By optimizing schedule, we can cut down emissions and make flights more efficient. And this is where sustainable analytics frameworks comes in. So to address the challenges we discussed, airline needs a sustainable analytics framework, a system that uses artificial intelligence, machine learning, and big data to optimize airline operations. So this frameworks reduces emissions, lower fuel costs, and enhances sustainability efforts. It also helps airlines comply with global sustainability regulations, ensuring long-term environmental responsibility. So this frameworks is built on 4 key components, each playing an important role in improving airline sustainability. So we have data collection. The first step is gathering flight data, weather patterns, fuel usage, and passenger trends. This helps airlines understand their operations better. Also, second is the optimization and analytics, where we use AI and machine learning algorithms to analyze this data and find the most fuel-efficient routes, reduce idle time, and improve passenger load balancing. Also, real-time insights is important, that it helps airline make informed decisions on scheduling, aircraft allocation, and route planning. And it helps them provide eco-friendly travel options. So the last one is compliance and impact tracking. So this framework ensures that airlines meet sustainability regulation like ICAO, IATA, and CORSIA, while also tracking emissions reduction progress. So what are the real-world benefits of this framework? Here's how it makes a difference. So first benefits is that the AI helps airlines select most fuel-efficient path, cutting unnecessary fuel burn, and it reduces the operation cost as well. So second one actually is lower carbon emission. So by reducing waste, airline decreases their overall environmental footprint. And also they can provide eco-friendly travel options. Passengers can get insight into their carbon footprint and can make more sustainable choices. Another benefit is better scheduling and load factors. So flight runs closer to full capacity, reducing the number of empty seats. Regulatory compliance is another benefit. Airline meets strict and environmental guidelines, avoiding penalties and maintaining a positive brand image. Finally, a stronger market reputation. So eco-conscious travelers are more likely to choose airlines prioritizing sustainability. Ultimately, this isn't just good for the planet, it's also good for the business too.
Hi, I'm Chloe. I'm going to be talking about parts of our framework, first starting with the optimization of flight routes. Here I'm going to be talking about user-preferred routing and the Advanced Air Traffic Management System. So first starting with user-preferred routing, or UPR for short. This allows pilots to select their own flight paths instead of following the fixed airway path. This enables a more direct and fuel-efficient route. And the way this is implemented is that airlines would use real-time weather, wind patterns, and air traffic data to determine the optimal route to their destination. Some of the benefits of this include reducing the flight time and fuel consumption, and it also lowers carbon emissions and improves the overall flexibility of their operation. An example of this being implemented was done in Australia by Air Services in trials, and they saw that UPR helped reduce their fuel burn by up to 26 tons per year for every route, and it cut emissions by 82 tons of CO2 annually. Next is the application of advanced air traffic management systems, or ATM for short. This allows air traffic control through the use of automation and AI and satellite-based navigation to improve their overall flight efficiency. Some examples of this innovation being applied in the US includes NextGen, which uses GPS-based navigation for more efficient flight paths. And then in Europe, they applied CESAR, which aims to integrate AI and automation for their traffic flow to ensure that there's fewer delays in flights. And the benefits of applying this helps reduce the holding patterns of flights on the ground and any unnecessary fuel consumption while they're on the ground. This also improves their on-time performance and increases overall safety and efficiency of the flights. A case study of the application of these innovations include Finnair. So they looked at sustainability efforts in optimizing their route efficiency. So the problem they were seeing was that they would have high fuel consumption and emissions, which overall impacted their cost and sustainability efforts. So the way they navigated this was the use of AI in their planning software, which helped in optimizing their routes and saving fuel every flight. So the way they did this was through optimizing their fleet use. So they would change the aircraft based on what was more efficient for the number of passengers that they noticed were booked. So whether that be using a bigger or newer aircraft or using a smaller aircraft, depending on the demand, as well route optimization. So utilizing wind-assisted navigation was ideal, or direct flat flight paths to help figure out a route. Another strategy was continuous descent approach. So this is where the flight would reduce fuel burn when they are landing by having a straight descent or a smoother descent overall when they're landing. And then fleet modernization. So a lot of newer aircrafts would help reduce fuel use. So utilizing those, and an example is the Airbus A350, which reduces fuel use by 25%. So as a result of these implementations, they noticed that they are lowering the CO2 emissions that they have on their flights and overall the efficiency of their fuel. This led to cost savings through the optimization of the whole operation, and as well, they've shown the leadership within the sustainability side of aircrafts and the airline. Next, another part of our framework is reducing fuel consumption. This includes sustainable aviation fuels and fuel-efficient aircraft technology, and also other operational improvements. First, talking about sustainable aviation fuels, or SAF for short. These are alternative fuels derived from renewable sources, which include waste, oils, agricultural residues, and non-food crops. They are designed to be a direct replacement of the conventional jet fuels being used in planes today. The way this would be implemented was that they would look for sources that can be easily renewable and try to create a fuel output out of that to be used easily or integrate easily with the current aircrafts that we have today. Some of the benefits they saw was that this kind of fuel helps reduce the greenhouse gas emissions by up to 80% compared to the traditional jet fuel, and being able to easily blend with the conventional jet fuels makes it easy to integrate effectively into the current system we have today and used in the existing engines without needing to modify much. So some examples of this adoption is that as of 2 years ago in 2022, there was over 360,000 commercial flights that have used this alternative fuel at 46 different airports, primarily in the United States and in Europe. And then as well, the expansion of production of this, a lot of investments have been made, for example, in the US of the Department of Energy, where they have approved different loans to expand the refinery of these within the country that produce half of the sustainable aviation fuels. Next, looking at fuel-efficient aircraft technology. So the goal of this is to look at the different advancements and research initiatives that are done to overall improve the engine, the aerodynamic enhancements, and any initiatives and programs that are sustainable. So specifically for the integration of different innovations, there are engine improvements. So a lot of modern engines offer a 10% increase in fuel efficiency over any previous model. So it's more ideal to use them. Any aerodynamic enhancements. So taking reference like a bird flight, it helps use like an improved wing to reduce the fuel consumption and also just reduce noise pollution. And as well, lightweight materials. They have different new composites and material usages in the aircraft weight, which leads to significant fuel savings. Some research initiatives that are being done towards this new technology is the Clean Sky program in Europe, where they are a public-private partnership that focuses on the development of technologies that create more environmentally friendly aircrafts, and as well at Boeing, they have an eco demonstrator program where it's their initiative to test and implement these new technologies for improved fuel efficiency and reducing emissions. A case study of these adoptions of the sustainable aviation fuel is the Air France or KLM parent group. So they recently signed a 10-year agreement with Total Energies for about 1.9 billion liters or 1.5 million tons of this new sustainable aviation fuel. And this is produced directly from waste and residues. And it is mostly done in France and the Netherlands and other European countries. They saw this challenge of looking for alternative conventional jet fuel, especially with their large fleet. And they also want to increase sustainability efforts. So they were the kind of leader and the first adopters of this new fuel alternative. They saw that this whole fuel adoption cut or reduced the life cycle CO2 emissions by 75 to 90% compared to traditional fossil fuels. And as well, on top of adopting this in their aircrafts, they also looked at different partnerships to further improve the production of these new alternative fuel options. So they partnered with Sky NRG to develop Europe's first dedicated production plant for SAF in the Netherlands. And this uses a lot of different regional waste streams, like cooking oil, for example, sustainable hydrogen, and they were able to achieve an 85% CO2 reduction as a result. And this airline specifically is committed to purchasing a specific amount of tons annually from this facility to further improve the production of these. So they saw as a result that they were basically a leader in this field, and now more aircrafts or airlines are seeing the benefits of applying this and have also started to look into signing different partnerships with these production plants or getting production plants up and running in their countries and getting it going. And as a result of that, it also increases demand for this production and overall reduces our CO2 emissions.
So, I'm Marianne and I'm going to be presenting. So, airlines can enhance sustainability with key operational changes. Single engine taxing. So, using one engine used during taxing saves fuel. Continuous descent. Optimizing landing pads lowers fuel burn. Regular cleanings. Cleaner engines improve efficiency. Lightweight materials. Reducing aircraft weight improves fuel consumption. So this small but effective adjustment helps to cut costs and emissions without major infrastructure changes. So talking about minimizing carbon efficiency, so there are two ways we're talking about solving this problem: carbon offset program and CORSIA framework. So carbon offset programs. So even with sustainable practices, flights still produce emission. Carbon offset programs allow airlines to compensate by investing in eco projects. So how it works is you calculate a flight's carbon footprint, offer passengers or airlines the option to buy carbon credits, then invest in projects like reforestation, clean energy, or emission reduction. For example, Emirates participated in emission trading system to meet sustainable targets while supporting global carbon reduction efforts. So the next method for reducing carbon emission or minimizing carbon emission is CORSIA, Carbon Offsetting and Reduction Scheme for International Aviation. So developed by ICAO, International Civil Aviation Organization, helps to stabilize aviation emission worldwide. So the benefits is standardized global carbon tracking, investment in certified emission reduction projects, and also encourage airlines to adopt sustainable strategies. So why data-driven decision making in terms of sustainable airlines? So data analytics is critical for sustainable aviation. Airlines use real-time tracking and AI to cut waste and improve emission. So key applications you can see this in carbon emission tracking, energy efficiency, waste management, supply chain transparency. So by leveraging big data and AI, airlines make smarter, eco-friendly decisions while enhancing operational efficiency. So we'll talk about one case study, which is Lufthansa Group's partner with Google Cloud. So Lufthansa partnered with Google Cloud to optimize airline operations through AI-driven data analytics. So the challenges that they faced was they needed better flight planning and efficiency, and also high fuel consumption and operational cost at the time. So the solution was cloud-based AI platform integrating fleet and passenger fuel and fuel data. Use Google BigQuery and Vertex AI for real-time efficiency tracking. So the result from integrating this solution was 7,400 tons of CO2 gas saved annually. So emissions saved annually. Optimize flight route and reduce delay. So this shows how AI-powered analytics can revolutionize sustainability in aviation. So talk about challenges. Challenges. One is that implementing a sustainable analytic framework has its own challenges that we know. Data complexity, integrating multiple data sources can be difficult. Real-time processing, high computational demands can be hard to manage. Passenger behavior. So encouraging eco-friendly choices, regulatory compliances, adapting to evolving sustainability laws. So despite these hurdles, the aviation industry is making strides in sustainability. So the key takeaway is optimize flight paths, reduce fuel burn, sustainability fuel SAF at the future, AI-driven analytics enhance efficiency, and also carbon offset program help balance emission. So by adopting smart analytics, AI, and greener fuels, airlines can balance profitability with environmental responsibility, ensuring a sustainable future for air travel. Thank you.